Hi, I'm Bob Alsop with ShopSabre CNC. Around here they call me Routerbob. Today I want to do a video about making your first cabinet on your new ShopSabre IS 510. Today we're going to be using Mozaik software to create our first base cabinet. But before we do that, let's take a closer look at the IS 510 that we're going to be using to make this cabinet. This machine has a 5x10 table, and I selected that because of the material size that I need to be able to use. It's also a vacuum table, and I need that because I need to be able to use flow-through fixturing to hold those parts of sheet goods. Now, something else I added on here is part locator pins because it makes it easier to load and unload those sheets on the table. Now, something else this machine's going to be used for is not panel processing, so I put the T-slot feature on here to be able to do special setups. This machine has our exclusive Super Z technology. It has an HSD ATC spindle and of course a 10-position tool changer. Since this machine is an IS, it's one of our machine tool grade CNC routers. That means it's precision ball screw drives, that means it's contour guide rails, that means it's an AC closed loop digital servo, and of course our ShopSabre MMP machine control system. If you want more information on the IS CNC routers, you can go to ShopSabre.com and watch a special video just on how we build these machines. Now let's go take a look at the software. Well, it's always exciting when your new machine arrives, you've got your software and you want to make something. Well, what I want to do is I want to do a little quick start here to show you how to make that first base cabinet. But before we do that, let's talk about what you need to do in terms of training to become proficient in Mozaik. Okay, what you see on the screen is actually Mozaik when you first open it up. And really the first thing you do to learn to use it is to go to the Help menu and go to Training Videos. And there's lots and lots of training videos on virtually any topic. Start at the beginning, Introduction to Mozaik, and watch that video. Now, you go through those videos. As you're going through the videos and playing with the software, if there's something you don't understand, jot down, make a note, make a list, ask Mozaik. You're going to have a couple hours of online training with Mozaik that's actually included with the software. Use that time to get those questions answered. And also, you know, sometimes you may want to purchase additional training. Maybe you're doing some kind of special kind of cabinet that's not standard. Maybe you need some help. So you can always purchase additional training if you need it. Now, let's look at the basics of the software. Okay, before you actually open a job, let's talk about a couple topics. One's materials and how that's managed. And up here, there's a list of libraries, and one of them happens to be materials. And this is a listing of the different materials that we have available. Now, the ones you see here are the ones that are installed by default, and of course, you can add other materials. And one of the things that you do want to do is you want to make sure that the dimensions are correct and the thickness is correct. And so if the material is actually 0.72, you need to plug that in there because then the software will use that to calculate joint fit. One other part of material that you might have interest in is the width trim and length trim. That has to do with how close the software nests to the edge of the material. That way we get rid of the factory edges. Okay, now, then materials are actually used in what are called material templates. And a material template simply says, this is what I make each part out of. So here's a material template called 3/4 plywood, and this is where I tell it what I'm using. You see, here's the thickness I just plugged in. So that's how the software in a job knows what material to use for everything. So that's the first part of it, all right? So now let's close that. There's some other libraries also. There's a library that has to do with hardware. So that's pulls, fasteners, all those kinds of things. And once again, there's already hardware installed in there, and you can add the stuff that you use. Then there's another one called products. And products are basically categories of different catalogs. So, and by that I mean custom frame cabinets, frameless cabinets, so forth. And then within those, the parameters determine how the cabinet's built. Now let's stop a little bit and let's talk about how you want to build a CNC cabinet. I've got the product editor open and I'm looking at the frameless 2018 catalog. There's a whole list of different catalogs. Well, let's pick a frameless one. I'm going to pick a cabinet that's a pair of doors, single drawer, and this is what it looks like. Now, let's take a look at, let's take a look at what that cabinet looks like. So I'm going to go over here to View SketchUp. It's going to open up SketchUp. And this is pretty close to a default cabinet, but you know, it's not exactly what I want. In other words, I want my cabinet built a certain way, because I call this a CNC construction method, because now we have a CNC, we can make cabinets a special way so they fit a certain way. So I want to show you how you actually turn that cabinet into that construction method. All right, so this is a default cabinet. Well, what's wrong with it? Well, let's look at it. All right, well, there's two stretchers, okay. Now I've got a nailer. Now on my material template, instead of a little thin back, I use a thick back, so I really don't need nailers, so I need to get rid of the nailers. And, let's just do one thing at a time. Okay, well, what controls nailers, all right? Go to Parameters, go to this category called Nailers, and here's case nailer width, 4 inches. Let's make that 0. And I'm going to hit OK, and let's go back and look at that cabinet again. Okay, and my nailer's gone. All right, it's actually, okay, now, so instead of having nailers, I've just got one back that's thicker. Now the other thing is I'd rather not have that so far back, so let's change that. All right, and so that's going to be in a parameter called back, I believe. And it says how far is it? Unfinished back recess, 3/4, so make that 1/4. So you get the idea, you fix one thing and then you view it. You visually validate it. Okay, now our back's fixed. Oh, okay, so I like that. What else we need to fix in there? Okay, I like that, I like that. Everything looks pretty good. Okay, how does the bottom look? Oh, now I want the bottom to actually go on out. I really want that back dadoed in, so I want that bottom to extend out. Okay, let's look at that. All right, so that's going to be, it's a parameter, and that one's this right here. Okay, back, bottom joint, base cabinet. Now you see it says plant on. You say, well, I don't know what all that means. Well, here's what you do. Select that variable. Let's hit plant on again. Let's select that variable and then hit this. Now it shows you that's what a plant on looks like. This is what a case depth looks like. This is what a flush with back looks like. This is what I want case depth. Okay, so I come over here. Instead of plant on, oops, that's I got the wrong one. I want base back, wall cabinet, back bottom, there we go. Okay, I want a case depth. Let's hit OK and let's check that out. Okay, we'll take a look at that. Yep. Now you see how the back sticks underneath here, and if we X-ray it, you'll see there's no dado in there because we haven't turned the dados on yet, but the position of the part, if it were a butt joint, everything's fine. So I'm happy with that. But you notice I don't have any dados turned on in my cabinet. So now let's do that. The basic structure I'm real pleased with. Now let's fix that. Okay, so we'll close this. Okay, so we're going to go to a parameter called dados. All right, and let's see, whoops, there they are. Okay, top dado. Top into ends. Okay, we probably want that to go about 1/4 inch. Okay, dado bottom into ends, probably 1/4. See what else we want. Fixed shelf dado, we'd want to dado that in. Partition dado, probably not. Depth for into backs, into ends. 1/4. Let's see where we're at. See what else we need here. Okay. Okay, I'm beginning to see the dados. There's the dados for the back. Okay, there's dado. Okay, yeah, now you can see the dados, but now we really want those to be blind dados. All right, so we've got the depth. Now let's fix the blind part. So we'll go back to this parameter called dados, and let's see, blind dado front, blind dado back. Blind dado front, I'm going to make 1. In the back, I'm going to make 1.5. And let's take a look at that. There we go. You see how the dados are blind here? There's blind there. There's that. Everything looks really good. Okay, I need a dado. I want to dado those stretchers in too. Let's do that. So you see the idea is you go through here, you find something, you change it, you validate it. Dados, let's see if we have a stretcher dado. It should be a drawer stretcher. Stretcher dado, that's it right there. Drawer stretcher dado depth. Let's go 1 inch, actually a 1/4 inch. Whoops, 1/4. Hit that. Okay, there it is. So now that one got dadoed in. All right, that looks really good. All right. Okay, so we've basically created the structure that we want to hold it together. Now I see something I don't like, and I'll show you. See all these adjustable shelf holes? Okay, let's change. I don't want that many holes. I'll show you where that's set. Parameters, that should be in, let's see if it's in boring. Yep, here it is. Minimum width part that receives the 3rd row, so let's go 25. See if that fixes that. Sometimes you just have to try something and see if it affects it. Okay, there we go. Now I've got 2 sets of holes. And also in those same parameters, it determines how many holes you put in there. In my case, I always put 5. Okay. Now, there's one other thing that I'm actually going to put on here, and think about this. I've got these blind dados. It sure would be nice on an unfinished end if I had a little screw hole in there to screw the cabinet together. So let's see if we can make that happen. The first thing I want to do is I want to go to the cabinet. Let's go to this end right here, and let's say this is an unfinished end. Okay, now let's go back, see what we get. All right, now that became an unfinished end, but guess what? It's got holes in it because the logic in the setup says if it's an unfinished end, put those holes in there so that when I get ready to assemble it, I've got holes to put screws in. Okay, now let me show you where that's actually determined. All right, that's actually determined right here under hardware, or fasteners, I believe, okay, where it says, see where it says CNC joint fasteners conformat? What that says is apply that joint to certain conditions, and the certain conditions are it's an unfinished end. Now let me show you where that was actually set at. There's actually, in our library, there's a set of hardware templates, and here's one called fasteners and joint templates that, if you remember, it was called conformat. This is what determines the spacing. So all the things that got applied were set right here. So everything like this is related. Okay, so now let's go back and look at our cabinet again, and it looked pretty good. So we go to products. Let's look at that base cabinet, and let's just look at it. I think we've made all the changes. And there we go. So on our unfinished end, we've got screw holes. On our finished end, we don't. All right, so that's pretty much what I call the CNC construction method. Now, let's carry that further, and now let's create a cabinet, and let's carry that through the process and take it over where we can machine it. Okay, we've taught the software how we want to build a frameless cabinet, so now let's go back outside and let's actually create a job. So I'm going to say File, New, File, New, and I'm going to name this IS 510. All right. Now that brings the settings up, okay? And the settings determine everything about the job. So for instance, what kind of hardware you're going to use. For instance, where it says hinges, I probably want to use a frameless hinge. Euro frameless, yep. What kind of guide rails you're going to use for your drawers and all that stuff. So all this is determined by that. Material settings, this determines which 3/4 cabinet, this determines which material template we're going to use. So we've looked at all those catalogs, and then this actually applies what we're going to use on this job. So look at it that way. Okay, and I'm going to say instead of settings for room, I don't really need a room. I want order entry. Now think about this. If I'm doing a room, I really need I'm going to design a kitchen or a bathroom or whatever, and I want a really nice picture for the customer. What if I just need a cabinet? there's also an order entry function where I can just say I want this cabinet, this size, and make it. So that's what we're going to do, because remember, our goal here is to cut that base cabinet out and see if it fits. So what I'm going to do over here, I'm going to say settings for order entry. Okay, and then instead of going to the room, I'm going straight to order entry. And that brings this up. All right, and I'm going to pick the catalog, and we were using Frameless 2018. I'm going to take that same pair of doors, drag it over here. Now I think if I make that 23 inches deep, it all fits on one sheet. All right, if we wanted to look at that cabinet, we can visually validate whether or not it's what we thought it is. And we could customize it at this point if we wanted to. Okay, that looks just like what we were working on. Okay, so one end is unfinished, one's finished, everything looks fine. All right, so that's the cabinet that we just designed. All right, so now we have that into the system. Okay, so I'm happy with that. Then we'll follow along the top here till we get to cut list. Okay, and I'm going to hit optimize in this, and I'm going to say I want to optimize the 3/4 inch plywood, and this turns the optimizer on. Now optimizing is another word for nesting. And here it comes. Okay, now let's take a look at optimization. Okay, let's see what we see at the optimizer right now. There's our material properties. If you remember, I put in 0.72 as the thickness, so that got carried over on all your trims. Now, here's actually a list of parts. There's a list of all the parts that are from that cabinet, and here's optimization. And what we're going to do is we're going to just say optimize. Like I say, optimization is nesting, and there's our parts. So that's how the software figured out to put all those parts on the sheet of material. But we're not quite ready to output code yet. We need to really set up the machine part, and we'll go do that now. But if you notice on there, you'll see all the details. There's all the dados, there's those holes. See, this is an unfinished end because there's the hole in the dado and there's not one in the finished. But before we can actually produce these, let's go back, and we need to go back to some libraries in the optimizer, and the first one's going to be machine. So let's take a look at that. Okay, first make sure that your machine is set as a CNC router, and I would also set that as a default machine. It is a CNC machine. Now if you have a multi-drill, you'd want to click that. In our case, we don't have one. All right, these will probably be fine. Most of these pattern cut, these have to do with sawing. All right, next go down to where it says Set Up CNC Router. Okay, you want to make sure you have the correct post processor. Now, there won't be one in there, so you'll have to get that from Mozaik or from ShopSabre. All right, and pretty much these other numbers are figured out. So Z clearance means how high the tool comes up before it traverses across a panel. Plunge clearance means where the actual feed rate in the material stops, and the rest of that should be set up. So that's the first part of machine setup, and we'll save that. The next part that we need to do is actually the tooling themselves, and let's go to CNC tooling, and so this is a library. You have a concept of what we call a tool set. So I've created the tool set here called IS 408. Okay, and tool number 1 is a 5mm drill. Tool number 2 is a 3/8 downshear. Tool number 3 is a 3/8 compression. Each of the actual feed rates and things are built into here. There's 8,000 inches per minute, so forth. So each tool is defined that way. So that determines how fast the tool cuts. Right? And then this order determines the order in your machine. So you make sure the 5mm drill is in tool 1, tool position 2 is the 3/8 downshear, tool 3 is the 3/8 compression. So now that gets that part set up. Once we've got that configured, now we're actually ready to generate the G code to create the nest that you see on the screen. Now we have the tool set up and the machine set up. Now let's go back to our nest and let's actually apply the tool paths, and here's how we do that. Over here it says generate G code, and it brings this up. Make sure that the correct tool set's selected and a post processor. Once you select those the first time, it remembers them, and hit calculate, and there's the 3 tool paths. There's a drilling tool path, there's a pocketing tool path, and a profile tool path. And let's take a look at those. So let's select this first one, and we'll slow it down a little bit. And so let's say simulate the drilling. So there's a machine going around and drilling all of those holes, okay? Then let's go over here and let's say downshear. So this is a joinery. It's a non-through machining, and that's what those look like. So there's a groove in the back being cut. Okay, we'll stop that. And then the final toolpath is actually profile, and it's cutting the outside. Now watch real close and you'll see something. First off, these parts right here are small parts, so we have to make special precautions so that they don't move, and we're using what's called return onion skin. So watch, it'll cut first pass, first pass, first pass, first pass. Now it'll go back and cut through them again, and that's called return onion skin, and that's how you hold small parts. And then when those are done, then it'll cut the remainder of the large parts. And those are getting cut. All right, so that came out really, really, really nice. Okay, so we're finished with that, or almost finished. Okay, now then the next thing we need to do is output the G-code. All right, now let me tell you where it's outputting it. Okay, within your Mozaik directory, there is a folder called Jobs. Within that folder is another folder with the job name. In our case, it's IS 510. Then there's a folder that says G-code and the material, and that's where the name of the file will be. And that's where it'll save it, and this is what the program looks like. Now you're ready to take this out to the machine and actually run that cabinet. Let's go do that. Our cabinet came out really, really nice. It's always exciting to make that very first cabinet on your new CNC router. You know, something's neat. Look at how nice this wood grain came out on the inside, because one of the things we wanted to do was make the inside of the cabinet really attractive. Well, I hope you enjoyed the video. If you have any questions, you can contact us at ShopSabre.com. Thank you for watching.